Good afternoon, everyone. We are going to go ahead and get started as folks are still trying to log in. Thank you for joining us today for our webinar with MXD and Verve Industrial Protection. A few logistical notes before we jump into the content here. First and foremost, I'd like to let all attendees know that we are recording this session that includes Q&A. So I just want to point that out up front. The recording will be made available on MXD's website following the webinar. So you'll be able to find that there if you're interested in watching again or sharing with any colleagues. You'll be able to find it at MXD's website. Everyone who's joining is automatically muted. We will individually unmute folks at the end for the audience Q&A. In order to do that, you can go ahead and utilize the raise hand function through GoToWebinar, and we will individually unmute you if you have a question to ask John or Akin. And then you can also submit any questions that you have through the chat and questions box that you see in GoToWebinar. We've got some folks on the MXD side who are moderating the questions throughout, and we will answer the questions to the best of our ability. We'll try to get to all of them as they come through, and then we'll bubble any questions up to our speakers at the end for any that are a little bit heavier on the content. So with that, I would like to go ahead and introduce Akin, who is our Director of Cybersecurity for MXD. So Akin, go ahead and take it away.
Thank you, Katie. Good morning, good afternoon, everyone, depending on what part of the country you're on. So we have an interesting topic for discussion this morning, which is looking at how do we get ready for CMMC. As some of us might be aware, this is a new requirement that's coming down from the DoD, and it becomes a requirement that plays into whether or not you're even able to bid on upcoming contracts or contracts as they come up for renegotiations or recompete. So, so from that standpoint, it becomes an essential to do for a lot of companies that have do business with the DoD. But as I indicated, we've got a couple of topics blended here. One having to do with compliance and the other having to do with security. It's important to point out that these two might not be one and the same, but they could be complementary. So for some of us who are in charge of making key decisions around security for our companies, one of the things that we've probably become accustomed to is the challenge that comes with convincing leadership about investing in security. So more often than not, the key to doing that becomes compliance. So if you can go to management and let them know, hey, if we're not compliant with PCI or whatever, it's got implication for our ability to continue to do business. It takes on a different level of urgency and gets the attention of management. So likewise, we feel like maybe this falls into those categories in the sense that it's essential that you get CMMC certified, and we'll speak to the levels of certification that applies in subsequent slides. But more importantly, can we get compliant and get better secured all in one swoop? And I think that's our goal here. So if we take compliance as a box checking exercise, then maybe there's a great line of division or divide between the two. But if we approach compliance as an effort to get better secured, then we can actually achieve both objectives in one fell swoop. Next slide, please. So what is CMMC and what are we trying to protect? So as I might have alluded to, CMMC is the new to-be law of the land as it relates to demonstration of your security posture in order to be able to do business with the DoD. But more importantly, what are we trying to protect in implementing the CMMC framework? A little bit of a background. So the government had in place, or DoD specifically had in place some rules around cybersecurity posture for participation in government contracting. But these rules were not very well enforced. For the most part, it was attestation based, and it created an uneven playing ground to where some would like to do the right things and invest in getting better secure. Others would not. They would just attest to things that are not, knowing fully well that there's no validation behind it. They were able to get away with just attesting and moving forward. So this new framework creates not just an avenue for you to self-attest, but for an independent third party to come in and validate that you're actually doing the right things to get better secured. And therein lies the intersection of security and compliance. So on the one hand, you have a requirement that says you have to comply, but now you have the validation engine that comes behind to ensure this actually gets done. To more directly answer the first question about what we're trying to protect. So for contracting with the government, you have what you call federal contracting information. A subset of that every now and then would involve what we consider CUI, which is controlled unclassified information. These are unclassified information that reside or have a tendency as part of the contracting process to reside on non-government systems. So the government would like to be able to speak to some level of security around how those data sets are handled. Now, when it comes to manufacturing, which is a focus area for MXD as the National Center for Cybersecurity in Manufacturing, this takes on additional dimensions. So we're not just talking data in the format that most people are used to in other industries. We're also talking about CAD drawings and drawings that might be emblematic of the things that you need to produce parts that go into various government projects. So how do we secure that becomes a key consideration and maybe a nuance that maybe is not common across industry. So it's something that we have to continue to explore and make sure we better understand. So moving on to the next slide, please. So this is a high-level depiction of what CMMC represents. So here we have in the old framework, which is the DFARS framework captured in 800-171, there were no maturity levels required. So you had one level, 110 controls, and you are required to meet each one of them. Now, keep in mind that this was attestation based. So the other thing that was allowed is, should you be in the process of complying and discover you've met certain, say 90 of the 110, and you have additional 20 that you haven't fully met, you were allowed to prepare what is called a plan of action and milestones. So this is essentially your roadmap to accomplishing the balance of the controls that you're not currently in compliance with. Under the CMMC framework, the POAM, as is known, is no longer acceptable. So you have to be fully compliant with the requirements at each level to be certified at that level. So as you can see, there are 5 levels of certification. Each level has a number of practices that are required. So at level 1, you're required to have to perform 17 of the requirements. The other thing that I will point out is each successive level is cumulative. So as you get to level 2, you have additional 55 requirements that apply, and so that gives you a total of 72 controls or requirements or practices that you have to not only perform, but also document. So there's the additional dimension that's introduced as part of CMMC, At level 1, all you have to do is perform the controls and be able to show that those controls are actually, or those requirements and practices exist within your environment. But with CMMC, there's a maturity component to it, to where at level 2, you're not just performing those 72 practices, but you also have them documented. So you have policies, procedures that guide the performance of those activities. At level 3, you add another 58 set of practices. In addition to having them performed, documented, they also have to be managed. And managing them implies you have to have not just your policies and procedures, you have to have roles and responsibility assigned. You have to have ownership of each one of those activities that are being performed to get credit for at level 3. At level 4, you go into the review of the process, which implies now you generating data, you getting metrics from the system or from the practices that are being performed, and you're using information that are gained from those metrics to inform improvements to the process. So then you move on to level 5, which is just how you are using the information to optimize. So you're now going from maybe some of your manual processes become automated and streamlined. It also allows you the capability to focus on things like advanced persistent threat. So you have a certain level of maturity that allows you to respond and to actually predict. You get into some elements of predictive analytics based on data sets that are coming through your environment. Your analysis of that informs what you do to better prepare to respond to events in your environment. So moving on to the next slide, please. So as the National Center for Cybersecurity in Manufacturing, MXD has a role to play in helping our members as well as industry get ready for compliance with the requirements here. Now the question is, what do you need to do to get compliance? We'll speak a little bit more to what MXD is doing, but what we've done here is try to simplify a roadmap for compliance for a lot of our audience. So what are those things that if you do and if you do right, it helps you to be as ready for compliance as possible. So the first one being, what is your target level of certification? What is the desired level of certification? And that is based on the nature of the contract that you have and the nature of the data that you have access to based on the contract that you have or the business that you're doing with the government. So keep in mind that everybody is required to be at a minimum at level 1. So regardless of what type of data you get or don't have access to, you will be getting federal contracting information. So you'll be required to be at least at level 1. Beyond that, if you have access to more protected data sets that falls under the category of controlled unclassified information, the number of practices that you're required to demonstrate moves up incrementally from that point forward. So having identified your target level of certification based on the data that you have access to, the next thing for you to do is to determine what kind of help you need. In a lot of instances, because a bulk of the manufacturers across the industry fall under the category of small to medium manufacturers, we imagine they will need some form of help, consulting help, either in assessing the current posture and developing a roadmap for addressing whatever gaps exist. So determining what kind of help you need, technical help, otherwise in understanding the requirements and putting in place the controls that are necessary to help you get compliant is an important part of the journey. So having determined what kind of help you need, this help might help you walk you through a self-assessment. So it's quite possible you have access to tools that allow you to gauge your level of preparedness. So those things might not be as intuitive as you might think a lot of times. So the help could be part of what helps you to do that. So this is essentially getting a pulse for how close you are to be ready. So having conducted that, you implement solutions and practices to address whatever gaps come out of your initial attempt, either be it a self-assessment or a third-party performed assessment. Then this is not really a required step, but it's important that having implemented those solutions and practices, you might want to go through and just validate that those controls are actually there and the design is effective in achieving the objectives that you have in mind. And the last step being you request a certification review and get certified. To the next slide. So I mentioned what MXD is doing because we believe we have a role to play here in helping our members as well as the broader industry get compliance with the requirements. So to do that, we have what we call in a CMMC Readiness Assessment, which you can access on our website, CMMC, mxdusa.org/projects. And the objective of the project is twofold. We see some benefits in the project for our membership and industry at large, and we also see some benefit for other stakeholders in the process. So the benefits as we see for our members and industry at large is being able to perform that self-assessment that we indicated in the previous slide as one of the steps that's required to get compliance, and having a third party come through with a streamlined process that allows the validation of the controls that practices that the self-assessment has indicated is in place. So the other benefit is really the report and roadmap for addressing the gaps as the third party sees it, and which allows additional time for each of the participants to work on the areas that they need to work on to get ready for certification. What's in it for MXD? We have this study provides us with some learnings. A key one is what are those hidden costs of compliance? So as you can tell, based on some of the steps that we've described here, there's more to it than just paying a third party to come in and validate your controls. Maybe there are pre-work to be done. Maybe there are additional controls that need to be implemented prior to having a third party come in to certify. So those are hidden costs that we hope we'll be able to surface and present back to the stakeholders in the process. In addition to that, what are the best practices in the process and the bottlenecks as you go through the process of getting compliance and the assessment process itself? And those are key learnings that we hope to also be able to provide as feedback to the audience that we have in mind. With that said, I'm going to turn things over to John Livingston, who will walk us through the other side of the coin, keeping in mind that these two things are not necessarily the same. At the same time, they're not mutually exclusive. So John, take it away.
Thank you, Keen. Appreciate it. Just by way of introduction, I'm the CEO of Verve Industrial Protection. I've spent about 20 years of my career with McKinsey & Company prior to joining Verve about 5 years ago. Just background on us as a company, and which helps provide a little bit of the context to what I'm going to talk about today. So Verve has been in business for approximately 25 years, 26, I think at this point, as an industrial controls engineering firm. So we've been working on industrial IT, OT environments for over a quarter century. The team is mostly made up of engineers and folks who have been involved in the OT environment. Over the last roughly 12 years, we've been developing and deploying a platform we call the Verve Security Center, which is an integrated management platform for securing integrated IT, OT networks, very much of the kinds of things that we find in the defense industrial base. We've got dozens of clients across all various different industrial sectors. And then we have a range of services that we provide as well, which help our clients, once we deploy Verve, to actually enable protection in their environment. So as Akin mentioned earlier, closing the gaps that we find once Verve, the software is put in on things such as network security or endpoint security, et cetera. So that's just by way of background of myself and some of the context by which we come at this conversation today. So Akin had actually with 6 steps actually around how do you start to progress down this security journey. Obviously, CMMC is a great framework to help you get started, right? Identifying what target compliance level you want to be at. Each of those compliance levels requires a different level of security processes to satisfy that compliance, and then et cetera to go down the list. I think so first point we'd make is that the threat is very, very real. This isn't just the government saying, you need to do these steps because of some theory. This is real, and we'll talk a little bit about that. As Akin mentioned, compliance doesn't necessarily equal security. However, the framework can give you a good guide of the kinds of initiatives you should be taking, whether the regulation was in place or not. CMMC as a framework eventually ties back to the National Institute of Science and Technology Cybersecurity Framework, which is a pretty well-known and comprehensive framework. So if you're having a lot of questions, okay, well, what does this mean and how does it work, et cetera? The great news is that folks have been implementing around standards that are very similar to CMMC for a long time. And so there's a lot of experience and learnings about that. Next, self-assessments, as Akin mentioned, are very helpful to get you started. They give you a base level of awareness of where you are in your journey. But what you'll find is as you get into actually moving from a level 1 to a level 2, level 3 on the compliance side, or alternatively, really thinking of securing your environment, you'll need to get deeper into those systems and where your vulnerabilities lie. And then lastly, not surprisingly, the solutions to these things can be complicated. Just to give you a sense, there are over 5,000 cybersecurity companies, each one who has a tool or a solution that can help you become more secure. As a result, it's very complicated. So as we talk through this today, we'll talk a lot about how do you simplify this complexity? How do you create a way of integrating all these things you need to achieve into a more simple approach? So the first question is, why do we care about this? Why are we sitting around talking about cybersecurity? Well, first, foreign actors have already demonstrated successful infiltration. So we already know they have been in the systems of the defense industrial base and have stolen critical IP. And this supply chain risk is a critical source of vulnerability. So because the supply chains have become so integrated, these vulnerabilities flow as the information flows from one part of the supply chain to the next. Perhaps more importantly, industrial companies are also at risk, not just of targeted attacks, not just of foreign actors saying, I want to go steal this particular piece of IP, but from untargeted attacks around things like malware and ransomware that weren't even targeting an individual company, but because that company's security was weak, patches weren't deployed, et cetera, you have ransomware that infects the systems and causes significant financial harm and operational impact. And we'll talk a little bit about that. And then fourth, the industrial customer base or production base is unique in that it also has physical risks from cybersecurity. So if I'm a bank and somebody hacks me, okay, what's the worst thing that happens? People's information stolen, money is stolen. That is bad, obviously. But if I'm an industrial company and somebody hacks me, I can blow things up. I can hurt people. I can, if I'm a pharmaceutical company, a hacker can disrupt the chemical compounds. There's physical and safety risks that come at this. So it's a significantly higher bar and a greater risk when you get into the production systems. So we should care. We should absolutely care. We think about this as three broad types of risk. The first is what we refer to as the collateral damage. This is when I've said before, sometimes you aren't even targeted and you're hit. And these are the examples of companies like Merck or Mondelez or Maersk, where they weren't specifically targeted, but the malware infected their systems and cost them hundreds of millions of dollars. There's the inside attack, which is typically a disgruntled employee or someone who's actually has access and they can do damage. And then there's the more, I'll call it famous ones, the ones that we hear a lot about, where there is some foreign state actor. Oftentimes they have funky names that have gotten into systems, these quote unquote APTs, advanced persistent threats, and they either steal data or, in the case of things like Stuxnet, where the Israelis and the US government hacked into the Iranian centrifuges, you can cause physical damage to operational processes. So the reason we lay this out this way is it's much more likely that you will be potentially hit by collateral damage. There is ransomware all over the place all the time. And even if you're a small company who you think, oh, I'm not anybody's radar screen, if you are unpatched, if you are not secure, you can have the same thing happen to you that happened to Merck. And then similarly, in parallel, we look at the severity of the risk. Obviously, those are financially costly impacts as collateral damage. But what can really, really impact you from a risk, from a severity point of view, is if some foreign state actor specifically targets your company, the damage they can do, whether it be physical damage or information damage, is obviously much, much more significant. Just to give you some sense of the numbers here, obviously these companies are quite large, but this is just three examples. The financial impact from these attacks can be substantial. So Merck cost them $900 million plus. Norsk Hydro, it cost them $150 million, and they were very, very well prepared. We can talk more about that at some point, but they were very well prepared with backups and segmentation, et cetera. And Maersk was north of 500 million. It's a little unclear as to how far north of 500 million. But the dollar numbers are substantial when these malware and ransomware gets in. Not to mention, obviously, the national security risks within the defense industrial base. So short answer is, this is a big deal. It is very real. This isn't theory. We need to think about securing it. So where do what are the challenges that manufacturers are facing? Well, these are the questions that we hear from our clients. The first one is, okay, I hear CMMC, I hear NIST, I hear Center for Internet Security. There's all these different, ISA 99, there's all these different standards. How do we think about which ones we should use to give ourselves a roadmap? Secondly, where do we start? There's so many things I could do. How do I begin? Number three, I don't have the people who know how to do this. Where am I going to find the skills and the talent, and what kind of skills and talent do I need to look for? Fourth, how do I manage all of this? So, when I do my first assessment, there's going to be, a list of 30 things I could think of doing. That all involves new technology, new tools. How in the world am I going to manage all that? And then finally, how do we do this and not blow the budget? This all sounds very, very expensive. How do we do this in a cost-efficient way that doesn't blow the budget, particularly in a time when everybody's budgets are constrained? So given these questions, we started to put together some points of view about how you answer those questions. So the first question is, okay, so what standard am I going to pick? CMMC is only one of a number of cybersecurity frameworks that are out there, and they come in different types. So there's the regulatory ones, the ones where you're going to be fined or you're not going to get business if you can't satisfy. CMMC is one of them. NERC, SIP, and the power industry is another one of those. Then there's the advisory ones. What we mean by that is these are frameworks that either the government or private organizations have put out that give you advice on how do you think about getting started and how do you think about moving down a maturity journey, so to speak, to become more and more mature. But there's nobody going to come and audit you unless you decide internally that you want to be audited. Then there's things you can be accredited on, meaning you can get a stamp of approval on. MC is one, ISO is another. And on down this list. There's a variety of different ways we can think about the standards. If you're in the defense industrial base, CMMC is obviously important, but what you're likely going to find is that not all of your supply chain partners are going to use that standard. Many of them have chosen the CIS top 20 or have adjusted the CIS 20 to their particular needs. And while the D for your particular project may only require a certain security level, maturity level, reality is, given what we just talked about are the risks that come from this, basic good governance likely requires a more comprehensive approach to this, where you may want to look at a more broad standard or a more advisory type standard like the NIST Cybersecurity Framework or the CIS Top 20. So first question is, how do we pick from these? The good news is almost all of the frameworks have the same basic components at their foundation. So what we've done here is we've overlaid one of those frameworks on another. We've overlaid the CIS Top 20 on top of the NIST Cybersecurity Framework. The NIST Cybersecurity Framework is that wheel you see in the middle. It's a very simple way of bringing together the basics around how you think about cybersecurity. It all starts with identify. If you don't know what you've got, you can't protect it. We'll talk more about this identify piece, but the foundation of any security program begins with identifying your assets, the software that's out in your environment, what users, who has access, what the vulnerabilities are. Secondly, then, once you've identified, quote unquote, the problems, as it were, or the risks, then the next step is to protect them as best you can. And all the standards will call for some components of protect. That will include patching systems, bringing them up to the most recent version, eliminating vulnerabilities that exist in the software, securing configurations. This is things like ensuring that passwords have to be a certain length, deploying anti-malware or whitelisting so that you can make sure that malware can't spread on that computer. So that's a whole set of things around protection. Then there's the detect piece. And this is basically saying, okay, I know what I've got. I've tried to lock it down as much as I can. And now I'm going to monitor it. I'm going to detect if somebody somehow has gotten in and is starting to change the patterns of behavior on my systems that might indicate a threat is running around in my systems. Next is the response piece, meaning if I find something, I have to react to it. I have to have a process in place and a policy in place of, if I see something, what do I do about it? Do I remove the user? Do I just take that device quickly off the network? What am I going to do if I have a problem? And how quickly can I do it? And then finally, the recovery piece. This is, in case of emergency, break glass sort of thing. If things go really bad, how do I recover? How do I go and get a backup for that system and bring it back online? If I have malware running in my system, how am I going to recover and get it out of there so that I can start to do my business again? So again, these frameworks they sound complicated. We've done presentations to talk about essentially it all sounds like a different menu that you have to choose what cookie you're going to go with. The point is, this NIST cybersecurity framework, these 5 core elements, are a great way to think about simply getting started of what are the main components that you're going to want to think about. So as I mentioned, security begins with knowing what you have and being able to see and know what you have. So this is an example from our Verve Security Center, and whether you use ours or others, ensuring that you have a picture of all of my various assets. So across the top, what you see here are various types of assets in an environment. Make sure that it includes the manufacturer, because at some point the manufacturer is going to announce they've got a vulnerability or that their software or hardware is risk, and so you need to know where it is. Important to this is know how critical that asset is to your environment. Is this an asset that is controlling a critical process that if it were to go down, or if it were to put false information into the system could cause damage? Know the criticality of the asset. And then on the bottom here, what you see is know the risk score. So how at risk is that asset? So again, beginning with a robust view of your assets and your environment and what it looks like out there. These are the components that typically are called for by most of those standards. So they'll call for software and firmware inventory, meaning what is not just the operating system, but what's the application software, or if you have embedded devices like switches or PLCs, what's the firmware version? The reason we want to know that is so that we can understand if there are vulnerabilities available in that software. Configuration status, backup status. Is it backed up or not? Do you have a recent one in case you need to recover from backup? What are all the users and accounts, and have you controlled the users? Or are there a whole bunch of accounts that are dormant that somebody had because they worked there 10 years ago and we've never taken them off the system? What's the status of your anti-malware? How updated is it? Are the signatures, have you recently updated your antivirus? Or like in many manufacturing environments, have you not, because it requires downtime, it requires rebooting systems, which has implications for reliability on your system, and on down this list. So there's a in these standards, they're going to ask you, do you understand your system? And so having a tool, and obviously we've built one called Verve that does this, but finding a tool that allows you to build that visibility is critical. And there are different ways of doing this. This chart talks about some of those different ways. There's passive listening, and what that means is basically having a tap or a span port on your network devices and essentially watching the traffic as it goes through and listening to that traffic, essentially like being on a party line, as it were, and listening to the traffic that's going through that telephone conversation and being able to pull pieces out of that traffic. So that's at one end. And at the far end here is the way we do it and others do it, which is to actually go deep, deep, deep into those devices themselves, not just to listen to what they're saying, but actually physically or technically to talk to them and pull back information from them. Essentially, if you're thinking about that conversation, be part of that conversation and ask the device specific questions so that it will send you back the detailed information you need. What that information then does is it starts to give you a picture of what your risks are, what your vulnerabilities are. And you want to have that view based on the different types of assets. So in this case, you've got desktop assets, server assets, network assets, laptop assets, et cetera, across your environment, and how many vulnerabilities are present. Also important to note is when a vulnerability exists, is it about the confidentiality of the information? So is this a concern? Is that vulnerability going to allow an attacker to steal information, which is the bottom one on this chart, confidentiality? Could it cause an availability impact, meaning they can do what's called a denial of service, where you can't get access to that device? Or is it possibly going to cause integrity? And this is the one where the really big impact happens when somebody starts to mess with the data or the inputs into that system and can cause disruption, whether it be in a refinery or in a manufacturing facility or in a water treatment plant. It's that one where you start to have significant impact on people's safety. And then obviously you want to know which assets are the most risky, so you can focus your efforts on those. And then obviously you want to look at those other pieces of information on your assets. This is an example of the accounts and users. Do you have a lot of users who have expired passwords? Do you have a lot of inactive accounts, which have been inactive for a long time? Those are very, very risky if you've got those kinds of things. So I'll just pause here for a moment. These are the kinds of information. It's when you ask that, when that guy in the picture was asking, where do I begin? Once I've selected my framework, I have to begin with inventory. I need to understand what's out there in my system, because I can't do anything if I really don't have visibility into those assets in my network. I'm going to skip forward here a bit because we're going to run out of time a little bit. You all have this presentation distributed to you. Eventually, as you build that inventory and you build the visibility of what your risks are, you'll then want to build a priority roadmap. Now, obviously, if you're following the CMMC maturity model, there will be a logical set of initiatives you'll want to do to improve the maturity of your security over time. That maturity model very much lines up with the NIST Cybersecurity Framework, the Center for Internet Security, which is the CIS Top 20. And what you'll want to do is build your own version of this kind of a timeline and a roadmap. What are the first things I'm going to work on, kind of in that bottom left-hand side? And then how am I going to layer on protections from additional policies to more protection, to eventually getting into things that are, much more advanced, like advanced threat intel and threat detection, et cetera, and integrated incident response databases, et cetera. But at the beginning, you'll want to get at this core stuff that's on the bottom left here, and then build yourself a roadmap. And depending on your aspirations around CMMC, or the requirements of the data you're protecting, or frankly, the riskiness of your operational processes, you may accelerate this journey, or it may be something that you're going to do over a 2 or 3 year period of time. So that's a question. That was the question. How do I get started, and how do I think about getting, taking some steps? The next question is, what kind of people do I need? Where am I going to find these skills? I think one of the most important things that we have discovered here is there is a bit of a news cycle here that focuses on what's on the bottom of this page. All the quote unquote sexy stuff in cybersecurity is threat intel and big data and machine learning and anomaly detection, et cetera. The reality is that, roughly 15%, 16% of the jobs, of the tasks that people do related to cybersecurity are in that bottom piece. 75% of the jobs are in the basic foundations of systems management, IT or OT systems management. Things about securely provisioning your network architecture, making sure you have identity management in place. Things like patch management, making sure your patches are up to date, making sure your AV is up to date, making sure your backups are up to date. Understanding your vulnerabilities, knowing what vulnerabilities exist, responding to that and closing the gap on those vulnerabilities. They are primarily systems management functions. So when somebody says, oh, well, you need to hire, all of these big data people and, AI experts, et cetera. No. The first thing is make sure that you're building your base of systems management, whether that be IT or OT, but people who understand how do you manage these systems effectively. It's in the OT, i.e. the manufacturing side of the house, things like PLCs and protective relays and robots and drives, et cetera. Those tasks are often forgotten about, but they're absolutely critical to ensure you have a secure system to keep the bad guys out, so to speak. Obviously, we and others offer these kinds of services and skills. We bring people who have been doing this for a long time, and there are outsourced providers that can help you move down your journey of adding these skills in a scalable way if you're a small business and don't have the resources to hire all these folks internally. And then the next question is, okay, so how do I manage the complexity? So you laid out, John, you laid out that roadmap. Sounds interesting, but boy, that looks complicated. How do I manage all this? So our view is the first thing you start with is think about it as a platform approach that allows you to grow over time. Now, part of this is self-fulfilling. Because we believe this, we have built a platform that does this, but we strongly believe in the platform to simplify, get it all in one place so you have a single pane of glass to manage. Number two, quote unquote, close the loop from assessment to what we refer to as remediation, i.e., don't just go and detect things and know you've got a problem and then have to go to some other tool to fix it. Bring those tools together to allow you to quickly close the loop. So you see a problem and the tool then allows you to fix that problem. Number three, integrate IT and OT security. So often we hear this debate of OT is different from IT, and it is. And our platform is specifically built to deal with those OT differences. You need to recognize there are differences. There are sensitivities to things like PLCs, et cetera. But also it's important to recognize there are ways to bring those IT-like systems management, security management capabilities into OT, and you can do it without risking the OT operations. Happy to talk more, in the future about how you can do that. It's definitely possible. Think global and act local. What we mean by that is scale up the security resources to think about and prioritize the things you need to do to fix them, but rely on those local engineering control system team when you start to get into the plant environments who understand that system. Because if you start to do patch deployment across all of your OT environment, you will trip the plant and you could cause significant damage. So think about how you scale that globally, make sure your platform can analyze globally, but act locally. And then finally, low cost deployment. Make sure when you start to think about this platform, that it can deploy quickly and at low cost, because this can get expensive and take a long time if you're not careful. Obviously, I'm preaching to the choir here a little bit. This is what we believe in, so we built our platform to do this. But as you think about it, whether it be our platform or others, we would encourage you to think about these things. And so just a bit about how Verve does this is we have built it off of this NIST cybersecurity framework. And so what Verve provides a platform that does these pieces. It identifies all those requirements of the assets. It then allows you to do things like patch management and configuration management right from the console to quote unquote close that loop. It's necessary that you're going to detect things because you never are going to protect from every threat. And so being able to see in real time behaviors that are going on that might lead to a detection, might lead to a threat is critical. And Verve brings that into the platform as well. The response piece as well. So being able to quickly respond to a threat and take actions in your environment to stop that threat is a key component of our platform and one that you'll want as you go over time. And then finally, recovery to make sure you've got backups. And those backups are being done consistently and B, secure so that people can't actually attack the backups. So as we think about this platform then allows you to grow over time. So if you say, okay, I'm going to start at CMMC level 1, let's say, okay, I only need certain portions of a platform. Okay, now I want to move up the maturity curve. Okay, I'm now going to add additional functionality to a platform so that I can keep the same user interface, keep that same look and feel, the same pane of glass, but add additional functionalities to that. It also helps in being able to outsource and bring in third-party resources to help you, because those third parties can, again, be using a consistent solution as they add security maturity to your overall environment. I'm going to jump forward here a little bit, just talk a little bit about why we think this isn't just about software, this is also about services. So Verve, usually software is not enough, particularly as you get into smaller companies where you don't have the resources. So certainly, we think about the Verve Security Center as a core key element to that, but we also think about the need for two other types of services. One we call Design for Defense. So this helps with things like the assessments, helps build those roadmaps I showed you before, and then helps our clients actually fix things. Segment your network, harden your systems, change your configurations, patch things. Particularly in OT, these services are tricky. You don't want to trip the plant in that process, so you need people who understand both the IT side and the OT side. And then third, managed protection services. So we also realize that people can't do this all on their own, and so we provide a range of managed services. Our assumption is that as CMMC goes forward, more and more people are going to need someone to help them do this, because it's not something that a 100-person company is going to have the resources probably to do in-house. And so bringing together people who understand the IT and the OT to manage that protection services is key. So with that, I'll end my part. I know we're only going to have a few minutes for questions, but hopefully we've left at least a few minutes for questions.
Thank you so much, John. We do, in fact, have a few questions lined up. We'll try to get to as many as we can. The first question, both John and Akin, for either one of you, can you address the common response by small manufacturers, which is, I don't make anything too terribly important. I'm not, supplying directly to the Department of Defense. Why do I need to be so secure?
So I'll take that. So I think what's missing in that description is the understanding that a lot of times, I think John used the phrase collateral damage, right? So part of this is also recognizing that some of those attacks are not just collateral, where on the surface they might appear to be collateral, but the attacker has specific objectives in mind, and you're just a conduit. So it's using to leverage access to your system to get to other systems. So case in point, when you go back to, I'm going back to something that was in the news. So John mentions what's top of mind for most people is what's in the news. And what comes to mind is the target attack, right? It came through a HVAC vendor. So that would be the last place somebody would look to say, okay, is the HVAC vendor vulnerable to an attack? Well, the HVAC vendor might not see themselves as being vulnerable to an attack, but they were not the target in that instance. They were a conduit. So it just means we have to change our mindset in terms of how we think about these things. So John, I don't know if you have additional comments to add.
Oh, I think you nailed it. It's exactly what I would have said.
Perfect, thank you both. Our next question is, what is the relationship between PLC and ICS with CMMC?
Just to clarify, Katie, you said, what's the relationship between PLC and ICS?
And ICS with CMMC.
So I think what the question gets to is ICS is industrial control systems, and PLCs are components of an industrial control system. The CMMC standard, and Akin can talk more about this, focuses on the information risks of unclassified information, critical unclassified information. And so those PLCs may or may not contain that critical information. But if you go upstream from those PLCs, that information is often contained in the HMIs or other Windows type systems that are controlling those PLCs, because the design of the part or something like that has been transferred to that HMI so that the PLC can control the controller on the manufacturing equipment. And so as you move into the industrial control system, those are definitely within the scope of CMMC, because that critical that CUI may be contained on those devices. From a security point of view, hold CMMC to the side. PLCs are very, very much at risk because of the vulnerabilities that exist in them, and they can cause significant damage to your manufacturing process if a hacker were to get into them. Sorry, King.
No, I was just going to mention, I totally agree with that. So if we go back to the typical layout of a factory floor, you have the machines and equipment that produce the output, but the instructions have to come from some system somewhere. And so it could be that even if you take your CAD systems as an example, you have the CAD drawing that takes place on some form of computer. Then that instruction gets pushed down to the ICS and the HMI to actually produce the final output. And so how do we secure that information as it moves through the chain to get to the final product? Probably becomes a key consideration for CMMC, and how that CUI, regardless of where it resides on its journey to final production, has to be secured.
Awesome. Thank you both so much. And we're going to go ahead and wrap it up now. I know we've got just under a minute left here. I'd like to thank John and Akin so much both for giving this great presentation today and working with us on this. I'd also like to thank everybody who participated and joined in the webinar today. As I mentioned in the beginning, we will be circulating the slides following the webinar today, and we will also post the webinar recording on MXD's website, so you can always check there for any of our historic webinars to take a look at those. And then with that, I just, again, want to thank everyone for joining, and I hope that everyone has a great rest of your day.
Thank you all.